Hi, this is the Bit-Mage. This time we're going to discuss about building up the definitive GoLang setup in Emacs. So it's going to be a practical one. I am going to be going over the pragmatics and the philosophical choices of how I choose to develop in GoLang. This is something that I use professionally, and I've shipped with this setup, so it's kind of tested. And I mean, a programming language setup is yeah, something that is very close to a programmer. It's like a woodchopper's axe. So this is what I do for GoLang in Emacs, and let's get started. So this is again another one of those videos in the polyglotism series. I have another one that is for Emacs plus Python. Uh, Again, here you can expect I'll be covering my complete setup. Uh, I'll be going through a Sentinel project. We'll do some debugging, some navigation, some testing, what I think about how you actually navigate with code and stuff. And yeah, some tricks, tips, that sort of stuff. You can find me on my Twitter, and that's the blog. The comment section is actually the best place to get in touch with me because I do read all of the comments, and yeah, I do reply when you have a question, or yeah, if you have any critique or anything like that as well. The comment section is the best place to reach out quickly. Let's get started. So why Golang? I mean, rather than, let me just, yeah, this should help with readability. Yeah, so why Golang? I mean, it's actually, I find Golang to be quite I find it to be speed readable. It's just like, I don't know, reading English for me. Reading simpler English, not heavy philosophy, nor any technical stuff. It's just like it flows. So I've noticed that yeah, it's very easy to speed read Golang. It actually takes out the technicalities of the language away from it's hidden away than the actual engineering. You can actually think in terms of engineering a particular thing. So when I do see Golang, what I think is it's an engineering abstraction. I do not see it as a language. I do not see it as source code. I see it as achieving something very easily. I mean, I do not have to force myself to think like that when I'm reading Golang, and it's very easy to interpret. You can probably skim a lot of source code and understand the gist compared to any of the other languages. There's yeah, it's it has much simpler abstractions. It's very limited in terms of the abstractions that it has, and they're all very powerful. Of course, I mean, everything that it's Turing complete, so I'm going to talk about that. But even in terms of expressiveness, it's pretty powerful. Not just computationally covering all the problem spaces, what is coverable by the other languages, but I'm saying is expressiveness as well is not sacrificed much for simplicity. Now that's one of the reasons that I started looking to Golang, and of course it's the cloud native language. I mean, Docker, Kubernetes, everything is written in Golang, and it's like a pretty good place to be if you wish to contribute to open source in this space. It's the community is great, and yeah, it's quick to pick up and stuff. So this is now why I am into Golang, and I do use it professionally as well in the cloud computing domain. So let's get started with how to set it up, how I go about setting it up in Emacs, to be more specific, doom-emacs. But then it's all pretty transferable to any other version that you use. In Doom is just going to be some config flags, uh, some init flags, some package flags. In the others, you can extrapolate that stuff. You can to to be a little more precise, macro expand that stuff and see how it pans. So yeah, let's go. I am, by the way, using a key display, so my all of my keystrokes should be visible henceforth, and yeah, let's get started. So anything that I talk about, any package that I talk about, you can quickly see what I'm talking about with space HDM. So anything that I want to highlight, any flag that I undo can be done with space HDM. So for example, if I wanted to talk about say org, how I enable it in Doom, I could just do space HDM in org /lang org. That's the flag. If I click on it, you'll get more information and stuff. So anything that I talk about right now, if you miss it out in the video, or do miss it out in the video, you can just hit space HDM, get it on the, yeah, see the Doom help for that. Let's get started. So install Go first, and install LSP-mode. For LSP-mode, install Go please. So Go and Go please, these are the basic requirements to get started. So this is, yeah, you just do a binary install, export your path and stuff. So this is pretty much procedural stuff. Just follow instructions and you should be fine. Nothing out of the blue. Now I'm going to assume you have Go binary in your path. You can check that out with hitting Go version. So I do have Go 1.23 right now with me. So once that's there, you have Go installed. You would also want Go please. So again, installing Go please is something that you can do with this particular command. I already have it installed, so I don't need to run it again, but let's just see what it does. I mean, yeah, it should probably say it's already installed, I'm guessing. It is downloading stuff, I don't know why. Okay, anyway, while it does that, I am going to move on. Okay, it did. So again, I should have a Go please version as well. Yeah, there you go. I have a version 0.16. Yeah, so there's that. I have these two things. You have the essentials now, and now we can start building stuff. I am first going to enable a bunch of flags before I go. So you do that in your init.el, and what you're looking at specifically is your okay, so I'm going to search the whole file. I just type in go, wherever go occurs, this particular flag. So go plus LSP is what you want to enable. Uncomment that, add a plus LSP flag, and to see what actually happens throughout this whole thing, just hit space HDM. Whenever you do that, hit go. I have all the documentation that flag actually enables. So there's code completion, documentation lookup, does a REPL, auto formatting, everything with similar key bindings. We'll cover that. These are the module flags. I am not using tree setter. I am using LSP. So I don't quite usually use tree setter yet. I might soon. But yeah, for now I'm using LSP. These are the packages that you install based on. So these are the ones that are installed by default if you just enable Go. If you do activate an LSP, you would also want to initialize the tools LSP package. So that is again going to be somewhere in your init.el. That is going to be LSP. Let's search. Yeah. So this is what I've done. I have again, if you hit space SGM LSP, there's a whole bunch of extensions that you can have to it. So I've had the LSP peak stuff enabled as well. So there's that. All right. So a few more things that you'd like to get started with is I would also recommend you get a minimap enabled. So it gives you decent overview, a decent overview of the whole source file if it's pretty long at a glance. So I can just hit space. I've mapped it to space TM, and as you can see in the right buffer, all of my source can be viewed at a glance where I am in the source. Exactly, yeah. So it's I'm going to close it all and fold it all. Let's open it all. Yeah, it's a responsive index into where you are in your file at a glance. So you can enable and disable it based on if you're in the explorative mode or if you're focusing on a particular section of the code. I do usually do that, and you toggle that by space TM. That's what I have mapped it to. I don't know what the defaults are. So anything that I map to, yeah. So okay. By the way, any of my keys or anything like that, whatever I say, you can just hit space HF, and these are where you get all the help function as to what I'm doing in Emacs. So for example, I'm doing a minimap toggle. I could just hit a minimap. I can get all the bindings, all the functions that I have in terms of minimap. So the minimap mode toggle, I have mapped it to space TM. That's how I can see it, and all the other functionalities as well. What you want to do with it can be viewed from this particular self-documenting functionality of Emacs. Space HF, that's for the functions. Space HK is for keys, so that puts me in an operator pending mode. Whatever I hit after that will be interned and analyzed for what it is actually doing. So you can see the press key prompt at the lower bottom, so that's operator pending mode for which key. I am going to press space TM, and it's going to tell me what exactly it is doing. It's going to give me all the links to where I'm going, what I'm doing, and stuff. So again, yeah, so when I'm doing this in GoLang, if I press a particular key, any default bindings or whatever, if you're confused, just hit space HK, space HF, and one more thing that you can look into is space HV. This is for the variables, anything that you want to, yeah, see in your all of your Emacs environment. How are they evaluated? What is the current state? All of it can be analyzed from here. So if my minimap mode is toggled right now or not, I can also check that out. It's nil right now, that means it's not toggled. So yeah, if I toggle it and then I press space HV and minimap mode, it's T for true. So it's enabled, and you can see it's enabled. So pretty handy stuff. That is the self-documenting part of Emacs, and yeah, it enables itself to be learned easily. So that's one good thing that you should remember. Moving on, once you have these initial flags set up, we are going to work with a Sentinel repository now. So go ahead and clone. I was just reading the Go programming language book, the OG book that is somewhat an analog to the C programming language book by the same guys. I mean, the authors have uh, a non-null intersection for Go and C. So yeah, just go ahead and clone this. I am cloning it here, so it already exists. I am going to delete the old one so that we can get a fresh experience. All right, so I do have that repository out here right now. So this is how you would honestly work with a project. It's something that I had done, just for getting my Go chops refreshed, refurbished, whatever you wish to say. I mean, it'd been some time. It's a few months old repository. So what it essentially is it is a corpus builder, an XKCD corpus builder. It's from the fourth. Yeah, it's just an exercise from the fourth chapter of the GoPL book. But then I just lost my way, and I messed around a little, and yeah, I just went around adding some stuff. So let's focus on what it actually is. Whenever you're working with an LSP, you'll need it to know what package it is. So there's a Go mod XKCD. The module is XKCD out here. If you're working on an empty project, you'll first want to Go mod init with whatever you want to. So if this was an empty project, if this file did not exist, I just go XKCD and hit that, and the go.mod file will be created. So yeah, now that I have this, I can go ahead and open a Go file, and my LSP would be able to LSP-mode. That's my LSP interface with Emacs, what Emacs uses. Will be able to understand in what package I'm actually at. You can see my Go please server, the LSP server has been initialized in this particular folder. So in this not folder, I don't mean to say folder. LSP is using folders, but I'm on OpenSUSE, so it should be using directories. Sorry for that. maybe we should put in a pull request. Yeah, it's initialized in this directory. So yeah, I haven't done a bunch of stuff. I was just messing around. So let's see. The basic stuff you can navigate around. Of course, I'm using evil, so I'm moving around with evil key binding. So that's why you see the J and K's and G and capital G's. So if I go to a symbol, if I just let it hover, you'll get all the you'll get the usual pop-ups. If you want more information, you can hit Shift K. You will get more information on that, where the packages you can see. So this is a type, which is a map from integers to a pointer to comics. So an integer to a comic pointer map. Comic is again a struct that we'll look into later on. But these are the functions that this particular type implements. And yeah, if we hit enter on what yeah, so let's if I hit space. Okay, so all of your LSP mode bindings can be set to a particular keystroke. What I like to use is Control Alt L, Control, or some people might like to say it Control Meta L. So again, a self-documenting part of Emacs is whenever you're in operating pending mode, you'll get a buffer pop-up from below, which generates an overview of all the possible deductions of that particular operator pending mode based on what key you press next. So if I hit Control Alt L, I will get all. I'm going to let this. Yeah, I will get all the possibilities that I have to explore now. I can do formatting, the code actions. Again, it's using folders for F. I do not like that. It should be directories. It's an ick that I have, and probably a lot of people will have when they watch this. But whatever. Let's go to the speak. You can have help, refactor, toggle your work, or your overall LSP workspace. So these are generic LSP key bindings that are available in any language that you use in Emacs with LSP mode. They'll be implemented or not implemented based on what the server that the language provides implements or not doesn't implement. Gopls is somewhat complete in the sense I haven't experienced a lot of issues with gopls. So let's say if I wanted to test out the formatting functionalities, let's say I insert a bunch of spaces unnecessarily. If I hit Control Alt L and there's a formatting for an equal. So if I press equal, I'm going to get into formatting. Now it's going to show me the next particular thing that I want to do. I can either press equal to format the whole buffer, or I can press R to format the region that I've selected. I haven't selected any region right now, so I'm just going to press equal, and it's going to format stuff for me. So it's saying applying two edits to main.move, so it's probably just removed to a tab and I don't know, the spaces or whatever. So there's that. So there's basic formatting, and it is using Go format, so all of it's pretty handy if you're working on an open source code base and stuff. You don't need to actively. You can also configure it to save on format, but then I prefer not to do that. If you're working on large code bases, I don't want to, and I have a habit of just going colon W or just going space PS all the time. So I don't want to be invoking Go format again and again. That is something that I do not want. Yeah, so that's one thing. So again, let's see if I hit Control Alt L again, I can see what I have. Now let's try jumping around. We did explore corpus for a while. I want to see where the definition is. I can either jump directly to the definition with GD. I'm going to jump back out. So I pressed GD, I jumped in, and I Control O. I popped the buffer stack to go back out. I can press C, Control I again to go back in. But I don't want to stay in for a while. I'm going to go back later on. So let's hold that thought. Right now, I can also look at all the references. So I know the key bindings, but you can again explore it with the way I showed it to you. Control Alt L, G, R. These are all the references. Okay. I am going to hide myself for a while because it's hiding. Yeah, I'm going to hide myself for a while. Yep. So there you can see all the references. I am Control Alt G R. You can see all the references of that particular corpus where it occurs at a mini buffer. So let's zoom in a little. GR. Yeah. So it occurs in a main.go, an XKCD.go, and an XKCD test.go. How many occurrences there are in each of the files is also something that you can see. If I hit tab, I can see all the occurrences enumerated with the line numbers. If I hit enter on any one of these, I will hop to it. So let's hop to this present p function where it's implemented. And by the way, in the left sort of pop-up, you can see where you get a quick glance of the surroundings of that particular reference, that particular presence of that particular variable. So I'm just gonna hit let's say enter at this present p, this predicate function. I hit enter and I am at that function right now. So again, yeah, here you go. This is again, you just hopped back in. Again, if you just hover here and there, you can see there's pop-ups and stuff. There's again type help and stuff. If I hit Shift K, I'll get more info based on what is on that pop-up. If I want documentation, I can again hit Shift K. I can see stuff. I can jump into library functions as well. Wherever I want to, I'll jump out. Let's go back. Let's go to main.go. By the way, you can also do that. There's also a handy thing to manage your projects in Emacs. It's projectile. So go ahead and hit space. I'm going to enable my video screen again. So I'm back online. So yeah, I am back in Emacs again. So I am going to yeah, go ahead and hit space HDM, HDM, and hit projectile. I don't know what is it exactly. Projects. Let's init project management. What is there for project management? There should be a projectile somewhere. I don't know, it's not there. Projectile. I think projectile is enabled by default, so that's nice. Yeah, so that's kind of nice. So we're going to jump back out. We're going to pop the stack. We're going to go back into our project. Yeah, there we are. So to quickly search for all the files in this particular project, a project can be decided based on if you want it to be your Git repository root, or if you want it to be a particular file at that particular root. So you could even use your Go mode. It's all configurable. So I can see all the mappings based on say space HF, and I can just hit projectile, and I'll get all my mappings and yeah, all the functions that you can have access to for this particular project via projectile. What I'm going to do is I have a handy one mapped. So space is how I find files in this particular project. I just do space. I get a Helm buffer, a Helm completion buffer with all that I want for this particular project. If there would have been multiple directories, you would also be able to search those. Right now it's a flat structure, so don't need to look around too much. I'm just going to go into main.go. I'm back to main where I wanted to go. If I hit again space, I can just search everything. I also have a handy mapping to search all the to grep anything in the whole project in all files. I've mapped that to space /. So that is my search for this particular project. So if I wanted to see all the occurrences of, let's say, the boolean true, I mean the literal true, I just type in true and I get that. So if I hit enter, I'll be that particular place. I'll be in that particular place. Let's pop the stack. Okay, so that's some basic navigation. That's how LSP works. That's how you can do stuff. Let's go back to our index, our work index. We've done the navigation stuff. Code folding is handy. Yeah, let's do that. Yeah, this is a bunch of these are a bunch of this is a pretty long file, a lot of code folding stuff. I'll also show you a mini map. This is the mini map. So this is the length of it. It's like what, 290 lines, 290 lines somewhat. I would like to have an overview. I just hit space, I just hit Z, and I would like to fold it all. So if I just hit, I am seeing like whatever, which key is doing its own stuff. I'm going to hit M, and it folded all of it for me. So all of it can be viewed in this much space right now. This is how I usually work. If I write down a function, I just test it, I see it's working properly, and I just fold it down. So it's like working in black boxes. I mean, once you know the black box is working fine, once it is functional in the sense of the pure functional sense, given certain inputs and given certain inputs, and given that it does not have side effects, if it's giving the same output again and again in a reliable manner, based on whatever assertions that you have of your input, if they've been followed, if it's doing that, you don't want to be messing around with the details anymore. You don't want to be bothered with the details. So yeah, I like to work like this. If I wanted to say debug a particular function or edit it or see further explore, I could just hit space. I could just hit ZO. That will open that particular function. I could again, if I wanted to just focus on a particular section of the code as well, I could just fold smaller blocks as well. Any braced block that you see, I can close that or open that. So Z, C, and O. ZC for closing your blocks, ZO for opening your blocks. If you wanted to do it all at once, Z capital M to close all blocks, and Z capital R to open all blocks at the same time. That's code folding and stuff. Let's disable the mini map. Let's go back to our work, our presentation index. Code folding is covered. ZCM, ZOR. All works, as I already said, Go please is something that has been a good complete experience for LSP. So it's a first class citizen in for the people of for Go devs. So by Go devs I mean developers who develop the Go programming language. It's not something written by someone else. Go please. So it's pretty handy. I haven't had any issues so far with it. It's pretty quick. It does everything. And yeah, so we covered navigation and stuff. The operator pending mode that I did highlight is something that's going to be very handy for you to learn key bindings and not having to. It's like an interactive cheat sheet. Yeah, it's like an interactive cheat sheet. I also use one more thing for interactive cheat sheets. So you will a lot of times call the Go binary. Yeah, the Go binary. If you could just paste the Go H and get all of your help stuff out here, but I like to see it in buffers, and I mean, so there's something called as TLDR. It's good for, so I remember this from cheat sheets. I'm just plugging that in pretty quickly. Hit space HDM and press in TLDR. Cheat. I don't know what that is. Okay. I don't know what that is. Let's find out. I've forgotten what it is. So my key binding for that is space TT, and that gives me a TLDR. And whatever I press, it is connected. It has an internet connection. So I mean, for whatever CLI tool that I want to explore the cheat sheets for, I can search for it in a help completion buffer. And let's say I want to search for the Go tool, the Go CLI tool, what it does, all the flags and stuff. I hit enter, and it gives me a quick overview of what the basics are. So how you can quickly get started, install modernit. It's a quick overview. So for example, if I wanted to see how Go test, let's say SBCL, that's again common Lisp stuff. I will make a video on common Lisp again sometime. Yeah, that's what it does. So it's pretty basic. It's going to get you started. It's a quick index into. So yeah, it's quick index into. It doesn't replace the docs, but according to its name, it's the TLDR. So yeah. By the way, what module it is, I'm not sure. I'm just, so again, the self-documenting part of Emacs is something that I want to highlight. I don't know what TLDR is supplied by right now, so I'm just going to hit space HK, and I'm going to do a space TT. So that does a lookup that gives me the information as to what it is fetched by. It's from TLDR.el. Now, what provides TLDR.el? I'm not sure. I could also probably look that up. References, functions used. It's used in TLDR.el. Yeah, probably somewhere in the init. Maybe I've installed it in my packages.config. Have I? Yeah. Oh, this is something that I've installed independently. So a package TLDR is something that might be useful for you guys. Let's get back. That was a tangent, useful albeit, but fine. The minimap is something that we've also covered. So yeah. Again, space TM. It works in any buffer, by the way. Works in any buffer. Doesn't have to be a GoLang buffer. So fairly handy. I'm going to close again. I'm going to go into where I was. Okay, so we have, yeah, I already mentioned speed reading Go is somewhat possible. It's a very simple language. I mean, everything is pretty obvious. Once you see patterns, it's like fitting Lego blocks or shapes into templates. You don't have to think a lot in terms of what the language is doing, and it frees me up to think in terms of engineering what I want to do. So that is something that is worthy, and to maintain that when you're programming, you can leverage a few things. So a couple of things out there is snippets provided by YASnippets. So again, hit space HDM snippets. If you enable these, you get tooling agnostic snippets, but buffer aware snippets anywhere, any buffer that you're doing. Applies for Go as well. So one particular idiom that Go devs use a lot is, for example, the inserting error check snippet. So I am going to, let's zoom in a little. Let's create a buffer.go. Yeah, it's initialized some basic stuff for me. Let's just do a temp function that I don't want to explode, that I don't want to export. So it starts with a small case. So yeah, I don't want to interfere with the packages and stuff. So just a basic function. Okay, so let's say I want to just insert a snippet. Let's say I want a quick error check. So I can hit space is, and it's going to give me all the Go relevant snippets that I can insert. Again, in a Helm search buffer, a Helm completion buffer. So I can, it's all interactive. So if I hit air, it's going to be all the relevant snippets that have this particular substring in it. So, and I can scroll through them, control N and P, and they will be interactively. Did I just leak my email? I did. Yeah, it's okay. Space is, air, if r equals nil. Yeah, that's that. You see? So yeah, that's how you can just insert snippets. So I mean, compared to typing that stuff out, this is something that's pretty handy. Even when you're completing some functions, if I wanted to say call temp, let's say I wanted to, let's call a function. Where do I call it? Let's go to main.go and call a function on CRP. Again, dot completion, all of it is there. If I hit enter, let's say load from file, you get a, let's call a function that has multiple arguments. Dot that has multiple arguments, insert has multiple arguments. Okay, if I hit, it's going to give me, you cannot see it right now, but then right now I don't need to, I'm already in a different sort of mode. It's not an insert mode exactly, it's sort of a visual insert mode. So if I type in something right now, that particular variable is going to be replaced right away. If let's say I want the ID to be 90, I've inserted that, and I don't need to go escape insert mode and move forward and escape enter insert mode with a visual mode on comic again. I can just hit tab. Now the visual insert mode is on comics. So let's say I want this to be a foo bar or something. Yeah, and that's it. That's what I did. So usually you would have to jump in and out of modes and stuff, but this is something that's pretty handy that I did not find documented anywhere. But then it was like when I did find it, it was like a nice fresh of breath there. Nice breath of fresh air. I haven't had my morning coffee. It's like 5 in the morning, so do excuse me for that. It's again crp dot yeah, anything I choose, control nnp, I can move in out. So these are the methods, and these are, I don't know what exactly. This is a snippet, a capital S for a snippet, and M for a method. So let's say I want to clear this. Yeah, that particular snippet relevant to that particular entity that I'm using can be inserted right away. So again, if let's say it's pretty handy when I wanted to do something with variables. Let's say let's declare a string. I'm going to format for a while, and let's say I wanted to do with x that I want to imply a function on x, but something that's not a method of x. You can get access to those via snippets. Just hit x dot and you get everything. You can print it, you can split it, you can assign it to a variable, and all of this will happen with x put into that particular snippet. So this is pretty handy. Let's just choose the print. It's going to give me a fmt.printf. X is this particular value with x being that particular thing with the modifiers and everything. Now let's say this is printing x as what yeah, a value. So it's kind of nice. Let's do some more. Split is going to split x into what? It's a string. It's doing a string split. It knows that x is a string, so it's doing a string split. And it okay, by the way, it also inserted me immediately into the most sensible place where I would want to change anything. So I want to split via an S. I can just hit S and I'm there. So inserted my cursor there directly. I didn't have to worry a lot. So that is how a lot of Emacs makes it easy to abstract the language editing closer to your fingertips. I mean, you don't have to think of actually typing out format.printf or actually moving here and there, placing your cursors, getting in and out of insert mode. So you can actually focus on the engineering is what's actually kind of good about this whole setup of mine. I mean, I have VS Code and stuff, they work out of the box, cool, but then all of these things slowly add up. Your Helm completion buffer, your self-documenting part, all of these modules that interop together, these context-aware snippets. You don't have to learn multiple things for multiple languages. You can just LSP-mode key bindings are going to be the same. You can again, I mean, I don't want to get into LLMs again, but this is just a text buffer. You can just interact with LLMs right away, and you're using Vim bindings while you're at it. Throughout this whole particular demonstration, I haven't used the mouse, so it's actually fairly impressive for me what I can do with these things, and yeah, it slowly starts adding up. So you might think this might be somewhat tedious and I don't know, hectic to set up, but then once you invest a certain amount of time for, like, I don't know, maybe me personally, I took like 4 days of 8 hours, so like 30-40 hours to move from Vim to Emacs in terms of how proficient I am. So I read it like 5 years ago, in the summer of 2020. That was like peak COVID. I just made the switch in May of 2020 from Vim to Emacs, and it took me like 4 days worth of like a full day's job worth of time, 8 hours a day, and I was fairly comfortable, and I have been experiencing the dividends of that particular decision till date, 5 years down the line, and I can't even account how many minutes, how many accumulated minutes, hours, and days I have, or probably even a year. I must have saved in terms of just moving around here and there and figuring things out and like handling the mouse. So this is something that pays off with an initial investment, of course. So I am making a case for Emacs. So all of these things that I'm showing you, navigation, jumping, many mode buffers and stuff, they're all available in all of the editors out there. Any good editor worth its salt is going to have it. But then all of these together integrated in a smart manner that do not limit you to its own specific domain but make you competent in general at interacting with text is rare. And there are only a couple of things that would do it. There's Vim and Emacs, of course, but then I find Emacs to be a little on the higher side because of the abstraction it chooses itself to build with, chooses to build itself with, that abstraction being Lisp. So that's another video. But yeah, the highlight is that Emacs is going to help you transfer your skills across anything that you pick up later on. I mean, across all of the videos that I do, that is what I want to show. I just don't want to show you a development setup for GoLang, but Emacs is also the highlight in terms of how it makes you a more competent programmer, just a more competent manipulator of text in general. So enough of the philosophical rant. I'm going to go back to where I was. We saw snippets. Okay, so I personally started exploring TDD, test-driven development, with GoLang. Again, the engineering stuff is what GoLang is what I use for engineering. So TDD is something that I found interesting when I was building stuff. So again, I have bindings for that too. I can just hit space empty A to run all of my tests, and S to run all of a single test if I'm in that particular function and it has a testing functionality, or if I'm in the test file and I just want to test a particular small function. So I'm just first going to hop into my test file, XKCD.txt. I'm going to fold everything. These are all of my tests right now. Let's just say I wanted to test everything for now. I'm just going to hit space empty A. Okay, it's not compiling because I included the buffer.go and I'm not using a format in there. So let's just delete buffer.go. Yeah. Let's go back to tests and hit space empty A. What am I doing now? In main.go, I'm not using format. Okay, so I'm not using format, I'm not using strings. So let's just do an organize import. Okay, so highlighting what LSP can do, I'm just going to do an code actions via code actions and organize import. So Control Alt L A, and I'm going to organize imports with an enter. It removed whatever I was not using. I'm going to save everything with a space B capital S. I'm going to run an MTA. I can run an MTA from anywhere, by the way. I don't need to be in the test buffer, and it's going to pop up a temporary pop-up window at the bottom. Space MTA is going to run the tests. So for a quick overview, what I am doing with this particular test right now is for all the XKCD comics, it's finding on the last comic that was released via an exponential binary search. So it'll just find out the lower and higher bound for if a comic exists or if a comic does not exist based on the HTML error code received. So if a comic does not exist, you get a 404 at that particular URL, and if it does exist, you'll probably get a 200. So yeah, based on that, you'll find the lower and higher bounds, and after that, you can just do a binary search. So a binary search with, again, the predicate function, the test function being this particular differentiator, if a comic exists or does not exist based on your status codes. So that is something that was being tested right now. That's why you saw the iterations. But yeah, these are, again, that's pretty handy stuff. I could just run all the tests with space MTA. Let's go to the test file, xkcd.txt. yeah, this is what was particularly search limit. Yeah, this is what particularly was run. Let's say if I only wanted to run this, I could just hit space empty s, and because my browser cached stuff, it was much quicker this time. So the same requests happened much quicker. I mean, if I do clear my browser cache, this would have been slower. So yeah, it just ran this particular command. Usually you would have to, if you wanted to do this individually, you would have to open up your terminal, type this out, and then this would happen. So let's show it to you. Space OT. I am going to, okay, I need to be in the relevant directory. Yeah, there you go. You usually have to do it in a terminal like this, but then because of Emacs, I can just hit space empty s, and there's your answer. So in a buffer, conveniently, that is scrollable. And by the way, if you had an error, so I can just pretty much paste it anywhere right away via the same key bindings that I use in Emacs everywhere in an LLM buffer. So I'm not going to do it again, but yeah, so that sort of stuff is fairly indispensable. I mean, all of these integrations are fairly indispensable when it comes to being efficient and being a polyglot. So if you're just working across many languages at the same time, these things pay off. I mean, you can go ahead and use PyCharm for Python, or probably use Lem or whatever for Common Lisp someday, or you could use, I don't know, what are the editors these days, any of the IntelliJ stuff for any of the languages, but then having them integrated in one particular editor via similar interface is actually what enables a polyglot. So yeah, I mean, why learn multiple interfaces if they're all the same underneath, and why have that distinction? I mean, why have those boundaries? So that's what Emacs will help you with. So we did cover that. That is how you can quickly do some TDD stuff. Space MTS. You write your tests. You enter red because you do not have your Sentinel function populated. You keep on writing your keep on populating your function. Iterate upon it. You go from red to green, and you write your new tests. Hit space MTS again. Repeat. I've used it in production. I mean, for production code bases, it's nice. It's great. All right. So that's how the snappiness of tests and snippets help you stay in the engineering mode and not worry about the language superficialities. The language superficialities. Yeah. All right. Another handy thing is alt-x compile or meta-x compile. I mean, you can use it anywhere. I have it bound to space cc. It takes up the last command that you ran relevant to this particular project and is going to execute that for you. I don't want to run that. I just want to do a go build. Let's just do a go build. And it did not build because I'm in the wrong directory. I'm in the golang.org. Let's do a space cc here, go build, and it built. If I wanted to do a go run, I think I just hit space cc again. Go run. And it's gonna run the thing in a convenient buffer. Again, if you have errors, anything, you can again interact with an LLM buffer immediately. You don't need to do a lot of context switching. Again, if I wanted to repeat the last command again, I can just do, rather than a space c small c, I can do a space c capital C. It's going to run the last command again. So if you're like iterating quickly, it's fairly nice. That's alt-x compile for you. I usually also, if you want to observe the logs and stuff, if you're running servers, I usually use an Eshell buffer, or this is for ephemeral stuff. So I usually use space OE is how I pop it up, how I toggle it. I usually use it for ephemeral stuff that I would like to throw away immediately. If I want something to be more stateful, I would use space OT, the Vterm buffer, which has all my environments loaded and stuff. So you see the conda activated, you see where I am in this particular directory. If I change my directory here and I hit space OT again somewhere else, that particular directory will be remembered. And yeah, so this is the stateful one, and this is the stateless ephemeral one that I use. Space OE. Right now I'm in GoLang. Let's say if I move to my XKCD directory, and if I hit space OE, it's going to put me in the XKCD corpus builder directory, not the GoLang directory. But let's say if I hit space OE again, if I hit space OT here, let's say I move to my home directory, I close this and I hit space OT, I'm going to be in my home directory, and this is the same Vterm that I populated for any buffer. So your Eshell buffers, my Eshell buffers are separated via buffers. So you have a specific one for each buffers, and they're ephemeral. You can just throw them away, use them quickly and stuff. But my Vterm buffer is stateful, it's persistent, and that's what I use to maintain context across buffers. So that's some handy advice for you guys. All right, so let's move back to where we were. I showed you how to do some builds, runs, and by the way, you can run anything. If you have a make file, you could just do make here. So if you're on a C++ project, whatever you use, whatever build tooling you use, you just use that. I don't have a make file here. I could write any command out here. I mean, I could just type and stuff. I could just say echo test, and even that would be considered as a compile buffer for that particular project later on. So yeah, it's again, flexibility can't be beaten. Now we're getting into the complexities of this. Okay, so with any large project, I mean, you definitely don't want to be debugging it with print statements. Dap mode is something that you would want to look into. Go ahead and hit space HDM and debugger. So Dap mode is something that is a generic interface for debuggers in Emacs. I'm going to toggle out, and yeah, you need some module flags enabled. You'll need plus LSP from tools, and everything else you can use this with GDB, LLDB, whatever. For Go, you're going to need godelve. So go ahead and install that out here. This is the GitHub link. I'll push the link in the description. So yeah, with godelve, you can start using godelve with Dap mode in Emacs via LSP. All right. So for this section of the whole presentation, I'm going to turn down my video again because I would want the whole screen real estate. So I'll see you in a while. But yeah, now you should see the screen, and I have godelve installed. You just do a go install. I'm going to open the GitHub link for a while, show it to you guys. Just go to an install. I'm going to search for install. Yeah, here you go, enter. Yeah, these are the installation instructions. Just hit a go install. Yeah, this particular command. Yeah, you just hit that and you have delve installed. Check it out in your path if it's present in your path. Now, once we have that installed, I'm going to move back to where I was in Emacs. Let's close this for a while, and we're going to explore the debugger now. And for the debugger, let's work on a simpler project for starters. Let's build a debug project, and let's readme.md. Yeah, I'm going to create that. Sentinel Go project. Let's do a space OT, not a space OT. Let's do a space OE and do a Go mod init and do a debug Sentinel. That's the module that I'm working on. That's the package that I'm working with. It has created the Go mod file. Now I can start with an LSP. You need a Go mod file for the LSP. Let's just hit a create a main.go. Okay, so I have stuff active now. So Is my LSP active? Okay, let's just work in package main. Is my LSP active? Yeah, it's active. Okay, so let's ask my, where am I? Let's ask one of my LLMs to just create a sample Go program, a buggy. I mean, let's just step through stuff. Give me iterative fib in GoLang. Oh, that's there. We have a function. Let's write a main. We can get rid of the LLM now. All right, let's let's just call iterative fib on 10 and do a print on it. Yeah, that's it. This should compile. Let's hit space cc and do a go build. Let's do a go build, not a for starters. This is how you would go with the usual project. And the compilation finished. Let's do a space cc again and do a go run. And it's printing 55, so that's nice. Now let's say if I wanted to step through this particular code, let's see what I can do. How I toggle a particular breakpoint is in this particular file itself. Let's say if I wanted to toggle a break immediately when I enter the main function, I'm just going to do a space d bb. So that's going to create a breakpoint for me. You can see the white dot to the left. If I do a space d bb again, it's going to toggle that off. I don't want it at the top of the file, so let's disable that one. Now that my debugger file has been debug breakpoint has been initiated, I'm just gonna start debugging. I can start my debugger. I'm gonna do a space ds, and it's going to ask me for a bunch of initial configuration. That's how I want to set up. So I don't want to configure it with my executable. I could do that. I have built one. I could either launch the file configuration via godelve, or I could either launch the executable configuration. I don't see it right now. Yeah, executable configuration right now. I would go with the launch file configuration right now. I mean, you can explore the others later on. So I hit enter. It's going to start a whole bunch of buffers for me right now. Let's zoom a little out so we can see stuff clearly, and hit space tw. So it's going to wrap stuff for me. I just hit space tw to enable word wrap right now. So okay, so you see a bunch of things right now. You see all of your breakpoints to the leftmost buffer. I see my main.go. I have a launch file log. So anything that I print is going to be printed in the third buffer from the left, and on the rightmost three buffers you have your debug session states and stuff, your local expressions that you're watching, your debug sessions, whatever you have. And in the main.go buffer that we have, the second buffer from the left, you can see that you have a red pointer at where at the program counter right now, the address I mean the line at which the program currently is right now. So it's calling iterative fib 10. Let's okay, how you want to do this is you want to enable the Dap Hydra mode. I have mapped that to space dh. It is something similar to God mode in Emacs. That allows you to skip playing with the modifier keys, and rather than hitting space again and again, work with individual key presses. I'm going to hit space dh. It's going to give me a nice pop-up that shows whatever I can do for this particular session. So in terms of code navigation, code stepping, I can do like stepping in, out, continuing, restarting the frame, disconnecting, that sort of stuff. For this particular session, I can analyze threads, I can go up and down the stack frame, I can list locals, I can list breakpoint sessions, whatever I want. I can for toggling breakpoints, I can just introduce breakpoints by BB or deleting breakpoints. Let's say I want a breakpoint here. I hit BB. That's a new breakpoint, and you can see the leftmost buffer was populated. I'm going to toggle it off again. I don't want a breakpoint there because I'm just going to step in. That sort of stuff. So let's say I wanted to evaluate anything. I could just hit space E. I could just hit. I don't need to hit space. I'm just hitting EE, and it's going to help me eval stuff right now. Let's just say I wanted to eval a literal, and it gave me the answer. I mean, let's eval something more complicated. Let's just do 2 plus 3. That gave me 4. And you could eval anything out here. You could use your local variables and stuff. I don't have any local variables right now. Let's see if it evals iterative fib. It should give me a function. So yeah, main.iterative fib. It's returning that particular function signature. So yeah, that's your basic eval. You can also evaluate a region if you select something. If let's say I wanted to eval. Okay, I jumped out. I pressed O. I'm gonna quit. I'm gonna restart. I guess I'm gonna restart. Yeah, because I messed up a little. Do excuse me for that. I'm gonna add space rh again. All right. So I'm not gonna mess around. I'm gonna change the code a lot here right now. But that's the thing. You can eval stuff. You can toggle your breakpoints and stuff. Now let's the program counter is at where I hit the breakpoint, and I need to step in. So I'm gonna press I. The program counter was updated. Right now I'm in iterative fib, that particular function. I want to move on, so let's just press N. I'm there. Now let's say I wanted to start observing the locals, so I'm just going to do an SL, and SL is going to highlight the locals for me. So it's N, that's 10, and an R0, that's a temporary, that's an unnamed variable, and a reference variable, that is 0. That is probably the int that iterative fib returns. That's the value that has been initialized to the default value for an integer. That's R0. But let's step. If I'm stepping, A, B and A and B are being declared right now. So my locals, let's do my locals again. And now I hit N and I do an SL again. A and B should be in the locals. So there you see, they're in the right. I can watch any particular expressions as well. I can add an expression to be watched. So let's see, if I wanted to watch A plus B, I can just hit space EA, and let's say I wanted to watch A plus B. Now that particular watch expression is going to be added to the expressions buffer to the rightmost middle buffer. And now let's step again. If I hit N and if I hit N again, A plus B has been updated. Let's do an SL again, and your A and B have been updated again. Let's do an N again and an N again. The watched expression A plus B is being updated as A and B are updated. And if you hit SL again, your current locals are also being highlighted. So that is something that is pretty handy. I'm just going to hit a C to continue. It printed stuff and it exit all the buffers once the debug session, once the program finished execution. So it printed iterative fib 10 55 in that particular launch file log, and it exit everything from me. And you still have your Dap Hydra session active. If you wanted to quit everything, disconnect, you just hit space. You just hit no space. You just hit Shift Q. So that's it. Where am I? I just hit. It's terminated. It's disconnected. So it's already disconnected. So I just hit small Q to quit. All right, that's it. I can go ahead and close this. So that's how you debug stuff. So it's pretty. Yeah, I mean you cannot ask for anything more other than this. All of your usual languages, any of the usual languages that you use with Python, Go, if they do provide a Dap mode interface, all of these are going to stay the same. So you could do this with Go, you could do this with Python. Particularly with Python, I use PDB because I am more of I use Python mostly in servers that are not mine. I search into stuff, and PDB is pretty handy out there, so that's what I use there. I might make another video on PDB soon because that's pretty portable. But if you're developing, if you're working on large code bases, yeah, this is going to be fairly handy, and nothing beats this. Cool. So let's go back to our work index, our presentation index, where we were. We checked out the whole thing, and I think that's the end of the video. We are done for the day. There's a whole lot more to explore. I mean, I also haven't completely explored all of what Emacs can do for you when it comes to augmenting your workflows, rather than just being a simple plug and play editor out there. So there's a whole lot more. There's a whole lot more. Uh, I mean, yeah, I'm going to enable my camera again. I should be in again. So there you go. Yeah. So that's pretty much all of it that I had to say that was on my mind right now for what I do for my GoLang dev in Emacs. And I think yeah. So do tell me what you liked, what you found interesting, what you can't do in the other editors, what's difficult to achieve in the other editors. What are your GoLang workflows? I mean, okay. So I've also used NeoVim for quite a lot for GoLang before. That is also a great place to be. But then yeah, nothing beats Emacs once you're competent with it. So yeah, nothing beats Emacs. I mean, I'm actually out there. I'm like, I mean, if I'm like getting into the war, I'm on Emacs sites. So the editor was it's like Emacs is the single most winner. I mean, any competent user of Emacs is not going to digress. So yeah, Emacs for GoLang setup. That's what it was. And thanks for tuning in. Again, the best way to reach out to me in this particular order is the comment section. Then we have Twitter. You also have my blog. Yeah, I mean, on my blog you can find my further details as to how you can reach out to me. So see you in the next one. This was the Bit-Mage. Hope you liked this one. Pretty long. I mean, I don't mind it being long. I just hope it was worth its value in time. So worth in value of your time. So your time and attention. So thanks for tuning in. This was the Bit-Mage. I'll see you in the next one and hope you have a good one.